Dear students, myself Professor Pramod Murari. I am Assistant Professor in Department of Electrical and Electronics Engineering, HIT NITSOC. Today I will be dealing with PSA subject, one of the concept called as symmetrical components. What are symmetrical components? Symmetrical components are the tools which are used in the analysis of the power system when it becomes unbalanced. In what way you will be doing analysis? You will be finding the unbalanced system voltages, unbalanced line currents, many more. Okay, before that you are going to observe what is a balanced system. In a balanced system, all the three phases are equal in magnitude. All the three phases are equal in magnitude. Okay, and the phase angle difference between any two phasors is 120-degree apart. So this is the balanced system. When the system becomes unbalanced, when there will be a unsymmetrical fault occurs on the power system becomes unbalanced. It means that all the phasors are having unequal magnitudes. Okay, all the phasors are having unequal magnitudes. Okay, say VA, VB and VC. Phasors will have unequal magnitude, and phase angle difference, you can observe phase angle difference between the any two phasor is not 120 degree. It is not 120 degree. Okay, it is not 120 degree. Doing analysis of such type of the unbalanced system using KVL, KCL and Thevenin theorem will take more time. That's why symmetrical components are defined. What are symmetrical components? How to define them? N unbalanced phasors are resolved into three sets of balanced phasors. As our power system is three-phase in nature, three unbalanced phasors, say VA, VB and VC, are resolved into three sets of balanced phasors. What are the three sets? The first set is called as positive symmetrical components. The second set is called as negative symmetrical components. The third set is called as zero symmetrical components. Symmetrical components are also called as sequence components. Let us know one by one what are positive symmetrical components. What are positive symmetrical components? Okay, positive symmetrical components are having the sequence same as the original unbalanced phasors. If the original unbalanced phasors are having the sequence as A, B, C in the clockwise direction, then the positive symmetrical components will also have the sequence A, B, C in the clockwise direction. Okay, then how to draw them? Positive symmetrical components, okay, they have the phasors of equal magnitude. I can represent the phasors here, say as VA1, VB1 and VC1. The phase angle difference between any two phasors is also is a 120-degree apart. Okay, here the number 1 stands for positive. How these phasors will rotate? These phasors will rotate in anti-clockwise direction. But the sequence is in clockwise. Phasor sequence is in clockwise. It is ABC. If the original unbalanced phasors are having sequence ABC, positive symmetrical components will also have the sequence as ABC. Then we will study what are negative symmetrical components, and how they are represented by means of phasors. Okay, negative symmetrical components will also look like positive symmetrical components in structure. Okay, they are having equal magnitudes, but the phase angle here, number 2 stands for negative symmetrical components. Here the rotation of the phasors is anti-clockwise direction. Rotation of phasor is anti-clockwise direction, but the sequence is A, C, B. If the original unbalanced phasors are having the sequence A, B, C, it is opposite to that. That is called as A, C, B. The phase angle difference is also 120 degree between any two phasors. Okay, let us move to zero symmetrical components. Zero symmetrical components. Zero symmetrical components will move in any direction. They are equal in all respect. Here I can represent them by as VA naught, VB naught and VC naught. As per the characteristics of zero symmetrical components, as they are equal in all respect, okay, VA naught is equals to VB naught is equals to VC naught. Okay, this is the relation between the zero symmetrical components of phase A, phase B and phase C. Okay, how to find the relations?